Today we're going to talk about graphing quadratics when they're written in standard form. We all know the graph of a quadratic is called a parabola, and that standard form is y equals ax squared plus bx plus c. You were introduced to this when we first started factoring and solving quadratics. In quadratic form, the axis of symmetry for a parabola can actually be defined using your a and b. We would say that the axis of symmetry, remember that's a vertical line, so x equals equation, negative b over 2a. The a and b come right from the coefficients in your standard form that you see there. And as long as you remember this formula, the vertex in standard form really is not that bad. The vertex, we all know, is the point that the axis of symmetry runs through. Therefore, the x value of the vertex in standard form is negative b over 2a. To find the y value, we're going to plug in that x value or evaluate the function at negative b over 2a. So this notation here, as complicated as it looks, is really saying plug in your x value to find the y. Some guideline steps to graphing in standard form. You want to find the axis of symmetry. Use that x value of the axis of symmetry to find your vertex. Plot your vertex, and then evaluate two x values on the same side of the vertex. So either go 1 to the right, 2 to the right, or 1 to the left, 2 to the left. Then we use symmetry to draw the other 2 points. Remember, when we go for parabolas, we can make a parabola out of 3 points. However, our parabola is going to have better shape if we use 5 points. So that's usually the goal. Sometimes we just can't fit that on our graph, and that's okay. Then draw your parabola that you shaped graph and identify the remaining features. We are looking for similar features that we were looking for in our vertex form. Now you might notice that in both vertex form and standard form, we had a as a constant, a coefficient. In vertex form, it was the coefficient of the parentheses. Here it's a coefficient of x squared. A actually tells us the direction that the parabola opens without doing any math. If a is positive, you open up, like in this case. If a is negative, we would open down. So our parabola in this first example opens up. It's always a good thing to check on in the beginning, because if you draw a parabola that opens down, huge red flag. Go back, you made a mistake. Our axis of symmetry is defined as x equals negative b over 2a. We know it's a vertical line, which means that we need to have x equals as part of our axis of symmetry. Negative b would be negative 6. Remember, we can label a, b, and c if that helps you out, like we did with our quadratic formula. So we find out the x value is 6 over 2 or 3. So our axis of symmetry is x equals 3. We know our vertex runs through that x value, or the x value of our vertex is 3. To find the y value, we need to plug in 3 for x to our original equation. In doing that, I find out that my y value for my vertex is 1, giving me a vertex point of 3, 1. Now we know some things about this already, and we know since my parabola opens up, that point 3, 1, my vertex, is going to be a minimum of the parabola. So any other points I find should be above that y value. The next thing we have to do to find the rest of the points on our parabola is to use a table of values. So we're going to be evaluating certain x values we choose to find the y and plot the point. Now I tend to go to the right, so I would check, x equals 4, x equals 5, but those numbers seem kind of big. I like to stick around like the 1s and the 2s and the 0s if I can. So I'm actually going to go to the left of this vertex. That is total free choice. If you want to go to the right every time, you can. If you want to go to the left every time, you can. the important thing is that when you choose a direction, you choose 2 x values in that direction. So in this case, I want to choose x equals 2 and x equals 1. I'm going to the left of my vertex to find more points. I'm going to plug those into my y equals equation. I get the point 2, 2 and 1, 5. We don't need to evaluate any more x values because we know that an axis of symmetry runs right through that vertex. So if I were to draw my axis of symmetry here, I'd be drawing a dotted line that runs right through this vertex. It's not an actual part of the graph though, so you want to make sure not to draw it too dark. I drew it in yellow here so that you could see. If we were to fold on that yellow dotted line, we could see that the purple points would transfer in these positions, or they would match up. So it's really no math for that. It's just using the properties of symmetry. So now that we have 5 points, we can kind of erase that axis of symmetry because it's not an actual part of our graph, and connect our points in that U parabola shape. We've already found some features that we're asked to find. For example, we have that it opens up, we have the axis of symmetry, we have the vertex. But we can use our graph to find all of the other features that we're asked about parabolas. So for example, the domain. Well, we know that domain of any parabola ever is going to be negative infinity to infinity. Remember, we point a little bit to the left and a little bit to the right with those arrows, even though they look like they're pointing straight up. The range in this one, our lowest y value is 1, which is included, so a bracket. And our highest x value is infinity, which we can never reach, so parentheses. So to find our y-intercept, we have to let x equal 0 in our original equation. Well, those would all turn into 0. So our y-intercept, which is a coordinate point, we won't accept y-intercepts that are not written as coordinate points, is x value of 0, that's what we plugged in, and y value of 10, what we evaluated it to. Looking at my graph, that kind of makes sense because I definitely haven't crossed the y-axis yet, and I probably will above the highest y value I have shown. So always check your graph to make sure your math makes sense, guys. And then we're asked about our x-intercepts. Now, this is one of the situations where, looking at our graph, our minimum point is y equals 1. That parabola is not crossing that x-axis. Therefore, our x-intercepts are imaginary. However, in the graphing world, we don't need to find imaginary x-intercepts. So, really easy one here. We just get to say none. There are no real x-intercepts. I can't do the math to find real x-intercepts because they don't exist. In our second example, we want to talk about how we could convert this standard form to vertex form. And you might be thinking, trick question, you showed us how to do this in the last set of notes by completing the square. And you're right, I did. I showed you that method. However, we have a new method. So we talked about how in vertex form how when x has a coefficient of 1, our vertex is shown to us as h comma k. And we talked about in this set of notes how to find the vertex of a parabola in standard form. We also talked about how a has the same meaning in both forms. And actually, a is going to be the same value in both forms. So in vertex form, our a is going to be 1/3, just like we see in our standard form. A is equal to 1/3. That means that if we could find the vertex of this parabola, we can write a vertex form equation to represent that standard form equation with the information we've been given. So to find h is going to be the x value of our vertex. We're going to use our formula negative b over 2a. In this case, a is equal to 1/3, b is equal to -2, and c is equal to -5. So negative b would be equal to -2, +2, over 2 times 1/3, which would be over 2/3. Well, remember a fraction bar is actually saying 2 divided by 2/3. And when we divide fractions, we multiply by the reciprocal. So this all boils down to 6 over 2, which is 3. In order to find k is the y value of the vertex. We know in standard form if we have the x value of the vertex, we plug that in to find the y value of the vertex. And I do have to say, because both these examples have x equals 3 as our vertex, that not every quadratic in standard form has a vertex with the x value equal to 3. There are other x values out there. It just happens to be a coincidence that I chose 2 examples where the x value of the vertex is 3. All right, let's find that k by plugging back in. So our k is the y value of the vertex evaluated at 3. We find our y value is 4. So if we know that a is equal to 1/3, h is equal to 3, and k is equal to 4, we have enough information to write vertex form of this quadratic equation. Our final answer would be y equals 1/3 x minus 3 squared plus 4. When you're writing any equation, you should have the variables y and x in your final answer, unless you have special cases of aligns. Those are really the only times where you won't see both of those variables.